Good morning, afternoon, or evening, wherever and whenever you are. My name is Benjamin, and welcome to another Godot tutorial video. In this video, we're going to be learning how to make a small laser that can detect walls, and it will create particles where it collides with those walls. This is loosely based off of an article by another Godot developer. It's an article from quite a while ago. He actually shared it with me on Tumblr, if that tells you how long ago it was. So I'll probably link to that in the description so you can check out his stuff as well. Maybe I'll link to his Twitter account because this is loosely based off of that. And you might, his is going to go in a little bit more in depth, so you can check out his article as well, his post about it as well. So let's get started. Let's do a new project here, and I'm going to browse and let's put this in. Here we go. And we'll come into reference projects, I think. No, YouTube tutorials. Here we go. Select this folder and we'll call this laser beam. And create folder, create and edit. Okay, once we've got this set up, we're going to need some resources. I'll link to the GitHub where these resources can be found as well, but it's nothing too special, to be honest. It's just a beam or a begin, which is just a circle, and then a beam, which is just kind of like we can look at them here so you can see them better. Right there, like this, we're going to be using these pieces to build our laser. Let's delete these, and we'll want to. This isn't as critical since our beam doesn't have a pattern, but if your beam does have a pattern, you want to come into, when you're importing it, you want to enable repeat on this and re-import it. That will allow the pattern inside of your beam sprite to repeat across the image. But like I said, for this one, it actually doesn't matter because it's the same all the way across this image. So we're going to create a new 2D scene. We'll call this world, and we'll come. Where am I? I'm zoomed clear in now. So we'll save. And we'll create another scene. This scene is actually going to be our laser. We can start with just a node 2D here, and we'll call this laser beam. And we'll attach some sprites here. So we'll need two sprites. We'll need a sprite for begin. So attach a sprite. We'll name this begin. And then we'll attach another sprite to our laser beam, another sprite node, and this one will be beam. Okay, and then we'll attach another node here. We'll just do a position 2D. This is where this is going to be the end of the laser beam. And you can actually use a sprite for this as well, but I'm just going to use a point, and we're going to create particles at this point. And then the last thing we need is we need a RayCast. Now the RayCast is how we're going to be detecting walls. If you saw in the example at the start, we could detect where a wall was and make sure that our laser beam never went through the walls but collided with the wall at that point. And so in order to do this really efficiently, we can use a RayCast. And a RayCast has a cast to property, and currently it's casting down to 50, and you can see it's kind of grayed out right now. And when they're grayed out like this, that means that they are not enabled. And you can see that over here, it's not enabled. So if we want to make sure and enable this, or else we won't be getting any collisions. We won't be detecting any collisions. And then we'll want to set our cast to 100 here, and then set our Y to 0. So we'll just cast to the right. And our end position, we're actually going to set its transform. In the X position, we'll set it to 100. So that should set it at the same position as our RayCast, right? Now we can set up our sprites. Let's drag the begin.png right there into our begin node and come to our beam. And for our beam, we're going to drag the beam texture like this. And we do not want the offset to be centered on the beam. That will mess up what we're doing here. In fact, we want our offset to be right here, centered vertically, but not horizontally. And so in order to do that, we'll set our Y offset to negative half the size of this image. And if we click on it here, we can see that it's 24 by 24. So we can set our offset to negative 12. And that gets us right in the middle there. That's exactly where we want to be with that. But we've got this black here around the edge. So how can we get rid of that? Well, we can use a new material here We'll just create a new material and we'll do a canvas item material. And we can use this material to tell Godot how to draw this sprite and which blend mode to use. And we want to use additive right here. And what that'll do is it will get rid of the black, that whatever was black in that image will become transparent, because that's how additive blending works. Okay, there we go. We still got some problems here though, because our beam doesn't extend all the way over here. So how can we do that? Well, if we come into the region right here in our sprite, we can actually enable this, and that shrinks it down real tiny, which isn't what we want. So when you enable the region here, you can actually see the texture. If we click texture region right here and zoom in, whoops, here we go. You can actually see the region that we currently have selected, and you can actually set this region up in here, and you can see it repeats, or you can set it manually over here, and we're going to be setting it manually. In fact, when we draw the laser in code, we're going to be manually setting the width of our region to extend the length of this laser. And so we'll set this to 0 and 0, and our height, we'll set this to 24, right? And our width, we want this to go clear over here to the same distance that we cast our ray, which was 100. So if we come back into our beam and set our width to 100 here, then it extends all the way over to the end here. Okay, so we set that manually here in the editor, but we can also set that in code. And you can see it's updated our region down here. We can just hide that by clicking on it. And so let's set this up in code. So let's create a new script on this, and we can let it be called laser beam. That's fine. We'll save this scene. We want to save this scene. Got our laser beam scene here, and we're going to get rid of this. So we need to get access to some of the different nodes that are attached to this laser beam scene, right? In order to manipulate them properly and set their length and stuff for the laser. So first though, we need our laser to have a max length, and that's because you can't have the laser go on forever, often to infinity. Unfortunately, our computers wouldn't be able to handle that, so we need to give them a max length. So we'll create a constant here called max length, and I'll set this equal to 2000, which should be good enough for the project that we're doing. In fact, your max length will probably be based off of how big your view is, your camera's boundaries. That way the laser can go outside the boundaries of the camera just far enough to make sure that it never gets cut off before the end of the view. Now we need to get access to our begin. Wait, do we need access to begin? I think I just grabbed access to it just because, but I don't think we actually need it. So we need to get access to the beam. So we'll call this beam equals, let's see, on ready var beam equals beam, like that. So that gets access to our beam node here, right? Now we have access to that. We also need access to the end. So on ready var end. And we also need access to the RayCast2D, RayCast2D equals RayCast2D. So there, we've got access to all of them that we need. Now we'll override our physics process update here. So physics process right here. This function is obviously called each physics tick of the game. And so we can use this to check for collisions and stuff inside of our raycast. So we'll say, first we want to get the mouse position. Mouse position equals get local mouse position. So that gets the mouse position relative to our laser beam, relative to the root, the very start of the laser. And we say var max cast 2. So this is going to be a vector that holds the position, the farthest position that we can cast to based off the mouse's position. So what we'll do is mouse position.normalized, and normalized just takes the vector to the mouse and it sets its length to 1. So this is basically a vector that points towards the mouse, but only with a distance of 1, right? Well, we don't want it to be a distance of 1. We want it to be the maximum length. So we multiply that then by max length, and that will get us the farthest position that we can cast to, pointing in the direction of the mouse. Now we can set up, we need to set our RayCast. So RayCast2D.cast2. This is the property that we set manually. Remember this, where we set its cast to equal to X and Y right here. Now we're going to be setting it in code based off of our max cast2, right? So we'll take this and paste it right here. And then we can say if RayCast2D dot is colliding. So we can check to see, oh, is this RayCast colliding with anything? And if it is, then we want to set our end. So this is the position, right? End dot global position equal to RayCast2D dot get collision point, like this. So what this does is we're able to, if we're colliding, then our RayCast2D can get a collision point, and it's basically, where did we collide? That's what it's saying. Where's the first point that we collided at? And so we're getting access to that, and we're setting our end position equal to that position right there. So this is, we've now determined where the collision is, and we'll set our end node, this right here, its position equal to the collision point, right, where we're colliding. Else, right, because maybe we're not colliding. Maybe there isn't anything in the way. If there's not anything in the way, then we want to set end.global position equal to RayCast.cast2. And what's inside of this right here? What is our cast2? Well, it's the max cast2 that we calculated based off of the mouse position and our maximum length. So we're just setting the end equal to the maximum cast2 as well. But I decided to set it to based off of the RayCast. Since I did it up here, I wanted to keep with that and do it here as well. Okay, so this already moves the end position, and we can actually run our game at this point. So let's save and press this little play scene button up here, which will just play the scene. And oh, we're not getting, well, it's probably working. We need to set our debugger and do visible collision shapes. Come up to debug visible collision shapes. That way we can actually see our RayCast, and you can see that it is following the mouse right here, and it looks like the maximum length is being done correctly because it's not casting to the mouse, it's casting past it. Theoretically, if we did everything right, it's casting 2,000 pixels past us there. That seems to be working. However, our beam isn't being updated properly, so there's two things we need to do with the beam. Number one, we need to make it so that the beam rotates towards the mouse, and rotates with the RayCast. We already have, the RayCast is already, pointing towards the mouse, so we can use its angle. So we'll say beam.rotation is equal to RayCast2D.cast2. Okay, that's the vector that we're casting to, dot angle. Now, angle is a function that is part of the vector class, and it just returns the angle of that vector. So we're setting our rotation to the angle of our RayCast2D, the vector that it's casting to, right? And now if we run the game, whoopsies, we've got an issue here, and I did cat2 instead of cast2. So typo there in my code. And you can see now the laser is rotating towards the mouse, but the cast, this right here, isn't actually updating its length. So how would we do that? Well, if you remember at the start of the video, we talked about the rect right here, the RegionRect and the height, right? Or the width, actually. The width is what we're going to be changing because we set that to 100. That's how we can choose how long this beam is. And so we can set that here. We'll just go beam.RegionRect end. Now, why am I doing end? Let's look this up so that you can see. If you look up the RegionRect inside of a sprite, so the RegionRect property under sprite here, this is the documentation. You can see that this is actually a Rect2D, which is a form of data, right? We've been talking about vectors. Well, a Rect2D is a form of data like a vector, but it's different. Now this has a position, a size, and an end. Now the end is actually how far over this it's basically it's a rectangle, right? And the end is the position of the very end of the rectangle. It's an X and Y position that gives us the end of the rectangle. So we're going to be setting the end of the rectangle, but we only need to set the X. So end.x. And you can see inside of each of these that each of these properties inside of the rect are vector 2's. So we can do .x right here. We'll set this equal to end.position.length. And that gets end.position.length. End here, this might have been a little bit of a bad choice of naming, is actually the end right here. Okay, it's the end of our laser. And so this is the end of our RegionRect right here. This is the end of our laser, and it has a position, and that position has a length, which is basically how far it is from the laser beam. So that's what we're setting this length to. Now we can run this test, and we should see our laser beam is working. It doesn't look super cool though, right? So let's come back into our world, and we'll instance the laser beam here. Inside of our world, you can just click this little button right here to instance a scene, and then we can add this scene to our world, and then we can drag it down, stick it somewhere in the middle of our room here. I'm going to turn on snap, and I'm going to set the snap properties. Configure snap. We're going to set this to 32 by 32 and close. There we go. So now we've got our snap set up to 32 by 32. For our world, we're going to add a static body. Now the static body will act as a solid wall for our laser beam. And it needs some sort of collision shape. I'm going to add a polygon collision shape to it right here. Collision polygon 2D. And once we have that selected right here, we can actually see we get these extra buttons up here, these context sensitive buttons. And we can use these to draw a polygon in this room. We click the little plus one. We'll come here. There we go. Okay. So we've got this polygon. We can save and run the game. It wants us to select a main scene. Let's select world here. And now you can see our laser is casting until it finds a spot to collide with, and then it stops, right? Now let's add the particles. Now the tutorial's basically over. You've got the gist of it, right? But I wanted to add a little bit of juice to this. So let's add some particles here. We'll add particles 2D to our end node. That way they're always at the end. And we'll set their lifetime to 0.25. I don't remember exactly what I set all these properties to. I don't know that I am going to worry about doing everything. We'll do a pre-process of 0.25. That just makes sure that the particles are processed a little bit right before starting the game. 8 particles, that's fine. We need a texture, so let's drag in our begin texture. We need a process material. This is what processes the particle. We'll do new particles material. And now you can see it's actually generating some particles, but we want to click on that so we can manipulate these a little bit. So we're going to come into gravity, set our gravity to 0. We don't want these to have any sort of a gravity, but we do want to give them a direction spread of 180, so they should spread out in all directions. We'll give them an initial velocity of 100 maybe, and you can see now they're going in different directions. And this is okay already what we have here, but let's do a color, and let's do a color ramp. And so we can add a new gradient here, click on that gradient, click here and do new gradient. Click on that and we can swap these. So grab the white and the black and swap their positions right here. So it'll start out white, fade to black, but we want our black. If we double click on this, it'll open up the actual color. We want this to be white too, but we want the alpha to be all the way down. And you can see now it fades out. Our gradient fades out at the end here. And so our particles start out white and then fade out. Let's see. If we come to our laser beam up here and then we go into our material, visibility, we can actually modulate and set this to be any color we want. Let's do like a cool red color. And remember how we made this right here do a blend mode for drawing? Well, we'll probably want to do that for our begin and our particles as well. So come into material on the begin. Just do a new material. You could use the same resource actually for all of these, but just to make things quicker, I'll just do this. Come into the particles at the end. And material, new material, blend, additive. Here we go. That's kind of cool, actually. Let's see, let's run our game with the particles on now. So we get some kind of interesting particles there. I don't want to have visible collision shapes on all the time. So in order to draw our polygon here, I'm going to attach a new polygon to this, and we'll do just a plain polygon 2D, and then we'll add a script to this. And this is a cool little trick that you can do. You can just, in the ready function, you can just get access to that polygon 2D, and you can set its polygon equal to the collision shapes polygon when the game is ready, and that will immediately draw the polygon, and then we can turn off visible collision shapes. Turn those off, and here we go. We've got an interesting little laser beam that automatically detects walls. And you might go, well, how can I make it damage something? What you would do, well, at least what I did when I was originally messing around with this, was I just set a collision on the end point. So I just create a little circular collision right here on the end, and then whatever collided with that took damage. And that seemed to work pretty well. So I actually really like how this turned out with the red. It looks super cool. That's going to be it. Hope you guys enjoyed. Well, actually, let me show you one more trick. Just because I remembered this. You can also set the texture on this polygon right here to be whatever you want. So we could do the Godot icon right here. And then when we run the game, we're going to get walls of Godot icons. However, I forgot you do need this texture to have repeat on. So let's enable repeat on the Godot icon and run the game. And there we go. Now that texture is repeated along this polygon. And so you could have some sort of a texture for your walls. So there you go. I hope you guys enjoyed this video. It was fun for me to make it. If you did enjoy it, be sure to like the video and comment down in the comments. I also have a Godot course that I am currently selling. And if you're interested in checking that out, there'll be a link to look at that as well. It's a 16-hour course, and the last section of the course I make a small Metroidvania project. I had a lot of fun doing that course. It was made possible by my Kickstarter backers, and so I appreciate all of the support that I've had on that. It makes it possible for me to continue making these free videos on YouTube, and I've got a lot more free videos planned here for YouTube. I'm excited to be making videos on YouTube again. Look forward to those. They should be coming here over the next few weeks, and I will talk to you all later.